Hello everyone, this is the North America Math Contest Go Go Go. Hello everyone, this is the South America Math Contest Go Go Go. Today we'll be working on Fermat Problem 24. There are functions in fx in such formats. For each of the equation, the value of the fq is calculated. The sum of all possible values for fpq is s. What are the rightmost two digits of s? So, by first of this, we know that fp it is equal to 17, right? So we can conclude that ap squared plus bp plus c is equal to 17. Because fp it is equal to f function, it is defined as this one. And this one, we plug in p, so we get this one. And we call this equation 1. What we are going to do next is that we use the same way to define the fq, where fq is equal to aq squared, is equal to aq squared, where it is equal to aq squared plus bq plus c, which is also equivalent to 17. So we call this equation 2. What we then need to do is that we can minus equation 1 by equation 2 to obtain a new equation, equation 3. So what this means that it is equal to and it's we minus the right side, it is equal to this. So this can be simplified into ap squared minus aq squared plus bp minus bq plus c minus c. This can further conclude as 2 which is this thing. What we then can do, we know that p is not equal to 2. So this means that p minus q, it will not be equal to 0. Why is this important? Because remember that we cannot divide both sides by 0, which is invalid. Because you cannot divide something by 0, it's undefined. So we must make sure, before factoring it, we must make sure that the common divisor is not 0. This is something we must be certain. Because if it is 0, then we divide it, it will be undefined, which will cause some errors to the problem. So we know that it is not 0, so we can divide both sides by p minus q, which we get. So we get this thing. So we call this thing equation 3. Now let's look at another conditions we have. fp plus q is equal to 47. We use the same way, like we plug p and q into the function fx, where we get f p plus q is equal to 47. So this means that a p plus q squared plus b p plus q plus c is equal to 47, right? What we then can do is that we can do another layer of factorization, which it will end up be plus c is equal to 47. One interesting thing that you can find for now is that this thing, it is equal to 0. See? So we can simply just plug in 0 to there. We can just simply plug in 0. And everything it times by 0 is 0. So this means that this can be further simplified into 0 plus C is equal to 47. So we get that C is 47. Now what we are going to do is that we can go back to the part of this. We plug in the fact C is equal to 47 into those two equations. Plug C is equal to 47 to FP, FQ. So we can obtain FP is equal to 17, which we can continue to expand him. AP squared, oh shit, what happened? Okay, never mind. AP squared plus BP plus C, which is 47, is equal to 17. So this means that AP squared plus BP is equal to negative 30, right? This is what we get. And then is P, AP plus B. We factor out the P. So this is what we get for P, for first equation. We can simply mirror the same thing for the Q. Will you just do the same thing for it, except to change P into Q? So similarly, it will be like this. It will be like this. So QAQ plus B is equal to negative 30. So from these two equations, we can know that P must be a prime factor of negative 30. Same to Q. This is the conclusion we can draw. Then the next conclusion that we can draw is that, just wait for a sec, P must be positive, because prime number can only be positive and larger than or equal to 2. So those are the two key conclusions we can get. Now we can just find out the prime factors of 30 is equal to 0, 2, 3, 5, 6, 10, 15, 30. You can find that those 8 factors are the factors of 30. Remember, I said factors here, not prime factors. So we need to find out the prime factors that lays inside them, which are those 3. 2, 5, 2, 3, 5. Okay. So this means that P must be, just wait for a sec, P must be one of the 2, 3, 5. Oh my god. 2 must be one of the 2, 3, 5, and Q also must be one of the 2, 3, 5s too. So remember that P must be less than Q. Combining those 3 factors, there are only 3 possible choices for like P and Q, which are P is equal to 2, Q is equal to 3. P is equal to 2, Q is equal to 5. P is equal to 3, Q is equal to 5. So those are the only 3 scenarios that for the P and Q. What we do is that we just test them out one by one to then discover the value of A and B. Because of this equation, we can use the value of P and Q to find A and B. So let's start. We start with the first case, right? Case 1. Case 1. So in this case, we know that the equations here are this and this. Just wait for a sec. Let me plug them here. And this one, right? So what we are going to do is that we plug in the value of P and Q, which is P is equal to 2. So it's 2a plus b is equal to negative 13, which this concludes to that 2a plus b is equal to negative 15. We know that the value of q in this case specifically is 3. So it's 3a plus b is equal to negative 13. So 3a plus b is equal to negative 10. We call this equation 4 and equation 5. We minus equation 5 by equation 4 to obtain equation 6. So we get that a is equal to 5 for the first case. We plug a is equal to 5 back to this one, back to this equation. Plug this one back to equation 4. So we obtain b is equal to negative 25. This is what we get for the first value. And then we know that c is equal to 47. From here, we know c is equal to 47. So what we are going to do next is that we can simply just plug it back to the original defined fx, where we get this one. And do you remember that the problem that we are required to solve is all the values for fpq? So we now already have the value of p and q respectively. We know p is equal to 2 and q is equal to 3, so pq itself is equal to 6. So it is equal to f6, and then you plug 6 back to here. The answer is simply going to be 77. This is the first value. What we are then going to do is that we are going to test the second case, which is p is equal to 2, q is equal to 5. Which we get, just wait for a sec, which we use literally the almost identical way as the problem there. So we still have this time p is equal to 2, so this equation doesn't change. However, this time q becomes 5. So it's 5a plus b is equal to negative 6. This is what we get. And then equation 6 is equal to equation 5 minus equation 4. Which is equal to, just wait for a sec, 5a plus b minus 2a plus b is equal to negative 6 minus negative 15 is equal to 9. So we get that 3a is equal to 9, a is equal to 3. We plug a is equal to 3 back into the original equation where we get b is equal to negative 21. So we have the value of a, b, and c. So remember that C is equal to 41. We already determined it right in the above. C is equal to 47. C is equal to 47, sorry. So we know that A is equal to 3, B is equal to negative 21, C is equal to 47. And we plug it back, and we know that the value of P is equal to 2. So Q is equal to 5. The value of PQ is equal to 10. So the common equation for this one will be 3x squared minus 21x plus 47, which is another case. And then we plug F10. X is equal to 10, which we get F10 is equal to 137. Okay, so now we have two distinct values here. Just wait for a sec. 77 and 137 for the two cases. Now we are going to test the last case, which is case 3. P is equal to 3, Q is equal to 5. P is equal to 3. So it's Q is equal to 5. And then we use the same way. Minus equation 5 from equation 4. So this is what we get. 3a plus b is equal to negative 6 plus or minus negative 10, which is 4. 4, right? So a is equal to 2. B, we plug it back, and we get b is equal to, just wait for a sec, 16. We plug this one back to the original equation, and we know that PQ is equal to 15 because P is equal to 3 and Q is equal to 5. So we know that FQ is equal to F15, which the final result is going to be 257. So now we have the 3 different values for FPQ. So we just sum them up. Sigma. F10, F6. We just sum the value we obtained from 3 different cases. We sum them up so that we obtain the ideal result, which is 257, 137, and 77. Which is equal to 394 plus 77 is equal to 471. I'm just doing double check. 394 plus 77. 471. Yeah, 471. So this means that our value is 471. And since the problem requests us to find the rightmost 2 digits, we just write down the rightmost 2 digits, which in this case, it is going to be 71. So the answer that we are going to type out ultimately is 71. Here we come to the end of our lesson, and I hope you have learned a lot. See you next week. Bye bye.